Hello there! Today we are talking about The Legend of Zelda, because yeah, turns out I play other games than PlanetSide 2. And I wanted to talk about this, Cryonis. That's a power you can use in Breath of the Wild to freeze water. And you can also break ice with it, but who cares? Now you see, freezing water is not easy. You need a lot of energy to do that, like a lot. Which brings the question, how powerful does the Sheikah Slate need to be to pull this off? Well, let's dive in. First we need to take a look at what we can do to freeze water. There are two things you can act on to make ice, temperature and pressure. You can lower the temperature of water, or you can increase the pressure exerted on it. In our case, since Cryonis works everywhere without requiring something to increase the pressure or anything, we can only assume that it works at atmospheric pressure, meaning that Cryonis makes ice by lowering the temperature of water. Also, the name Cryonis heavily suggests it, so let's go with that. So Cryonis works by lowering the temperature of the water to freezing temperature, 0 degrees Celsius at atmospheric pressure, and then turns that cold water into ice. Both of these steps require energy to be taken out of the water. Let me explain. First, the temperature. When you look very closely at a material or a liquid, you will see that the atoms and molecules wiggle about or move quite a lot. Individually, this causes each molecule to have a certain kinetic energy, which is the energy tied to movement. Then temperature is basically the macroscopic consequence of the atoms and molecules moving and wiggling. The more they wiggle, the higher the temperature is. So, to lower the temperature of water, you need to slow down the water molecules. You need to reduce their kinetic energy. So you need to take energy away from the water. How much energy you have to take away depends on how much water you have, how much you want the temperature to go down, and what material you are considering. That quantity is called heat capacity. The heat capacity of a material is the number of joules you need to go up or down 1 degree Celsius for 1 kilogram of that material. In the case of water, you need about 4,000 joules to drop 1 kilogram of water by 1 degree Celsius. For Cryonis, water needs to go from ambient temperature to freezing temperature. So one can consider a drop of about 21 degrees Celsius for however much water Cryonis is turning into ice, but we'll come back to that. The second energy requirement we need to take into account is how much energy you need to turn water into ice. Because bringing water to freezing point is not enough on its own. You need one extra kick of energy to solidify the water. That extra kick of energy is called heat of solidification, and it is equal to the negative of the heat of fusion, which is the kick of energy you need to turn ice into liquid water. For water, this quantity is equal to 334,000 joules per kilogram of water, which is a lot. It's equivalent to the energy of a 1-ton car being dropped from a height of 34 meters. So to summarize, Cryonis drops the temperature of water to freezing point and then takes an extra bit of energy to solidify the water. The only thing we now need to calculate how much energy all of this represents is the amount of water being turned into ice. To do that, we can simply measure the size of an ice block generated by Cryonis to get its volume. Multiply that volume by the density of ice and you get the total mass of the ice block. So we need the dimensions of a Cryonis ice block. We are going to estimate an order of magnitude instead of a precise value. Knowing that Link is about 1.6 meters tall, we can estimate that these ice blocks are about 3 meters tall and 2 meters wide. For a total volume of 12 cubic meters. That's a lot of ice. We can multiply that volume by the density of ice to get the total mass and we get 11 metric tons. So 11 tons of water are being changed into ice when Cryonis is used. So how much energy do you need to change all of that water into ice? Well, let's use all of what we've seen so far. First, we need to bring that mass of water from ambient temperature to freezing temperature. You do that by multiplying the mass by the temperature difference and the heat capacity of liquid water. Then you still need to change that cold water into ice. So you multiply that mass of water by the heat of solidification of water. You get this final equation. All we have to do now is plug the numbers in. We are just going to assume that the starting ambient temperature is 21 degrees Celsius. Let's put that into Wolfram Alpha and we get 4.6 gigajoules of energy. Still according to Wolfram Alpha, that's about the energy used annually by a clothes dryer. And all that energy just for a single block of ice. All of this is a bit extreme, but changing the temperature of water and then freezing it is not easy. It's a very energy intensive process. Now, with that value, we can come back to our original question. How powerful is Cryonis? Well, power is just energy over time, so we simply need to find out how much time does it take for Cryonis to make an ice block. Then we take the energy we calculated and divide it by the time. So let's look at the game. We record how long it takes to generate one ice block. We get 1.4 seconds, that's really fast. Cooling down and freezing 11 tons of water in such a short time is insane. Anyway, take the energy and divide it by the time and we get a power output of 3.3 gigawatts. Once again, Wolfram Alpha is nice enough to do my work for me and immediately tells me it's in the same orders of magnitude as the power output of a nuclear power plant. Okay, granted, Cryonis doesn't operate continuously at that power. These are only spikes of power, but still. This also raises another question. Where does all of that energy go? Because energy, just like mass, doesn't just disappear. It can only be displaced or change form. So all the energy that has been taken away from the water to freeze it has to go somewhere. I see two places where it could go. Maybe it goes right into the Sheikah slate and dissipates into heat, but that quantity of energy would be enough to make the slate melt immediately and turn into lava. Then maybe that energy goes into the surrounding water. It doesn't sound absurd, but then we could expect that water to get really hot and boil, which we do not observe in the game. Well, I guess I'll have to assume that it's just some Sheikah trickery. I also wonder what power source the Sheikah slate uses. I guess that's going to be a subject for another video. In any case, I hope you enjoyed the video. If you did, feel free to leave a like. If you want more of me being a nerd about things that absolutely don't need to be overthought, you can also subscribe and check out my Twitch channel. Thank you very much for watching.